Hello, welcome to another Eagle 6 Airsoft video. Just when I thought I wasn't going to try and do any videos again, just because they're a little bit time consuming, and it's been quite nice having the radio on and not doing these. I just thought for this customer I would just record this because he had some intellectual questions, if you know what I mean, obviously about you know, he enjoys the process of building up these guns, but have a little issue putting this back together again, and had genuine questions on obviously, you know, how and why and what he'd done sort of you know, wrong in not getting it back together again. So yeah, so I just thought I'd you know, just try and chronologue obviously what we're doing, you know, to try and get this resolved for him. So it may be incredibly simple, maybe not. We'll look over sort of what sort of the parts we've been given and see if we can get this figured out. You know, like I say, it could be something incredibly simple, but the customer said that he couldn't quite get that back in. So we're just going to have a look at that now and just see if we can figure out as to why that's not going back in. There was another thing I noticed on there, just a little mark there. I don't know what's. It's a relatively new gun, but. Start pointing out. Right, so we're just going to take this off. So we want to get to the receiver. So see the marks on here, if you know what I mean. So the rear pin is obviously, as you found out now, fake on the NGRS. It's only the front pin and then the trigger pin here, the trigger frame pin that goes through that holds the gearbox in situ. Just little note. It's one of those things where you don't do the same thing 20 times over, week in, week out. It tends to be difficult to remember like everything, and something I struggle with myself. So you know, there's thousands of airsoft guns, and everybody wants you to be an expert on all of them. Small nick in some cables, but that's not too bad. There's no obviously brakes or anything. We'll just get some extra heat shrink on those. Right, so we can take this off now, and there'll be a unit which will take off. Yeah, so the piston's got clearance, it doesn't seem to be impacting anything. So initially, just based upon, you know, everything that's here, There's a chunk taken out of this safety. That's quite weird. Seen that before. Hopefully that won't impact it. No, so it's almost like it was in that position there when pressed up. So isn't it? Right. So we'll just quickly try this inside the receiver just to see if there is a problem, and obviously we need to see that problem to be able to rectify said problem. So everything looks all good. It feels a little bit tight, which obviously we don't want that to be the case. Where's the frame pin? Let me just grab one of them. So we're just inputting in this on here just to locate this in a straight line, with obviously this pin locating this in the correct position. That's putting it in line, and then in theory we'd then install the grip to go on there. But it's just a smidge tight in it. And what I'm thinking is possibly pushing, maybe being a bit too proud. So like I say, so if it's, the issue was is that you physically couldn't get it into that lower receiver, obviously that's going in okay, but we do have this issue where, like I say, it's got some fouling going on. That's been glued in, so I can't access that. I'm just curious, it seems like it's off possibly at an angle. Just wondering if that's been seated at the wrong angle. Too bad. Just crack it out. Let's get that off and have a little look, see, just make sure. In theory, under a normal build, if we're just replacing internal parts, this should really not be ever be touched, but maybe it's got into that position through it being difficult to turn and it's pushed it. So the bit on there and the bit on there, there really should be only one. It's got a smidge of movement, but no, I think that was in the right place, so we'll just pop that back on. I need some grease. slightly different heights on these bushings. You've also got this one here, which is, I don't know if you can see when looking at this angle here, but it's almost like it's like that. So one side is almost flush, and the other side's quite proud. So obviously it's not great if the bushings are slightly askew. I mean, I'm all for obviously doing less work than more, but it looks like that may need to possibly be reseated, which then would adjust the shimming. But we'll get possibly get an amp reading, I think, before we start. I mean, we could obviously just have a crack at adjusting this, but what if I reseat this bushing, then obviously everything's all in a great in a better place after reseating it, and I wouldn't have to modify it then. I mean, it's going over the top, which is absolutely fine. However, like I say, once it's in situ, if obviously that's being too proud, then obviously we may need to just sand some height off that. In theory, they should all be equally as proud. Right, let's double check insides just to make sure. got a, you know, we've got a damaged cable there. So it's a good job we obviously come inside to check on that. What was that? Little clip to hold down the wires. So that's obviously popped up and caught on the pinion. So I'm just going to try and recover these shims, because we want to test those for you. I should take that spring out, shouldn't I? So I've got sector top. Let's reverse match. And cover the compression set. I'm going to gently lever this board top up. Look at the wiggling. Oh, so we've got some damage there. See how we can assess the damage as we're going in. That wire there is too proud, and it's basically rubbed away the wiring. I mean, this wire is not looking fantastic, is it? I mean, we may need to sort of separate this and or completely rewire now. And we could try and bridge them together, maybe pop a bit of heat shrink on there, join them back together again. We've got the damage up here. Obviously the ideal solution is all fresh new wiring, but it carries a risk, because obviously you have to then solder that onto the board here, which granted we've got our shiny new tips on the soldering iron, so we should be fairly good on that, but it doesn't half carry some risk. I mean, there's some risk to the board anyway, because I mean this may have already you know, damaged it. I mean, in my experience, they're incredibly robust, the gates. I know people obviously like to meme about them, but you know, the particular circuits, you know, components that they're using here, I mean, I'm pretty sure that's rated 160 amps, which is a huge you know, protection against like overcurrent and stuff like that. It's most of them, MOSFET manufacturers figured out ages ago that they have to build extra robustness into their products to account for customers. This is weird, isn't it, why that one's sitting so proud. We've got the underside of bevel and top of bevel. Right, so that's all shims recovered into the places they were already in. Yeah, I think with these two black ones, like I say, we can get away with some heat shrink. We can get away with like thing on there. I mean, like I said, I could just desolder that one and put a whole new one on, but just for that little bit of thing there, it just. And the only issue that might be is obviously if it's where the actual thing is, but that doesn't look like it. It just looks like maybe it's been caught between the actual gearbox and the lower receiver. We should be alright with heat shrink on there. Obviously we don't want these cables being too thick that obviously we can't put the gearbox into the correct position. Oh shit, we've got a shim here. Have I just caught that and brought that on there? I don't see any wide ones in there. I've got another small one there. Fuck, I hate finding shims. I thought of having all these over here. Yeah, I'd say it's fine. I mean, tiny bit of up and down bounce, but I think you would struggle to get rid of that without over shimming. So what we can do now is just double check the other ones and then just run a quick amp test on it. So it turns, and slackwise. It's got a smidge of movement there. I mean, I'll probably maybe try like a 0.1 on there just to sort of see if that will just take a bit of that out without, you know, going too tight. Pop this one in and just double check the heights. It seems awfully high, that sector gear, doesn't it? It's on stilts, look, it's like wobbling up there. And in some ways, like I say, that's also quite high. Not necessarily a problem, it's all about obviously what it interacts with. You know, obviously if it's also high that obviously it now hits on something, then obviously then it becomes an issue. So say for instance, obviously we pop in you know, the compression set, just remove this. So obviously what we can do is check for the height of its interaction with this rack. Yeah, so obviously what we ideally need is obviously you know, these teeth on this rack. Yeah, so what we don't want is obviously the teeth so low, which you see this definitely isn't going to be. We don't want it so low that it would say interact with that or maybe that. Yeah, you know, you know, too low it's going to hit there, and too high it's going to hit there. So we want somewhere obviously in the middle. Move them and see obviously where it exactly interacts. Without this top runner being on, it's not exactly in the right position, but it's pretty close. So yeah, I mean it's on the upper edge, you know, there's no two ways about that, but I would say that's fine. You know, smidge higher than what I probably would have done, but so look, when you actually straighten out the because remember this is going to have a another shell casing on there, which would obviously pull it maybe a bit this more direction. So now we are getting towards, you know, that upper edge of it. You know, shimming, and loads of people like to pull people's shimmers apart all the time. But truth is, you know, there's a large area of success. Yeah. Yeah. So wherever you are in the area of success, it's working. Yeah. So some people, like I say, will take apart somebody's shimmer and then say, well, this needs to be here because that's correct. You know, no, this one's correct. No, this one over here is correct. It's still all in the area of success, yeah. So as long as, like I say, it's in there, then we're good, you know. Obviously, when it's outside of it, over here, you know, we're hitting on something and something's not quite working. That's what we don't want. So obviously, we try and get perfect shimming in air quotes to maximise the chance of being bang dead in the centre of that area of success. Obviously we'd love to all be there, but you know, like I say, if we're around there, if you know what I mean, it's not too bad. So people get a bit too hung up on really trying to get to that centre of which, like I say, it's not necessarily being a bad thing, having those kinds of standards, if you know what I mean. So Right, I mean, like I say, if I had a preference, you know, thus far I'd probably maybe put half on there, and then I probably would just take some of the this sector gear off the bottom, and then I'll possibly just put it onto the top, if you know what I mean. But we'll just check out obviously the other one, which is the tappet plate. So so what you can do is put the tappet plate on there, and you know, without the spring, we can obviously check to see of the sector gear's height versus where that tappet plate is. So obviously, if there is no physical gap, you know, between obviously when we close the clamshells, you know, of the shells of the gearbox, and there's no physical gap between that and then the shell, and obviously it's pressing down on it, you know. So obviously, as it turns, you know, you can have this physical resistance of you know, possibly scratch and marking. I mean, the ultimate result being obviously a slow movement of this, because the spring's trying to return something with physical resistance, and obviously I mean, people go to the levels of polishing gearbox shells and in you know, making sure there's no burrs and stuff, you know, all in an effort for obviously speeding up the operation of parts. So friction, you know, from obviously you know, something pressing on the underside of this, it's not good. But we've got no obvious wear marks, you know, you tend to sort of see them in circles, you know, which suggests that, you know, it's not, certainly not causing a problem for the least amount. But obviously if it's not been used a huge amount, then, you know, that wear might not have presented yet. So we'll just do the quick test, which is just simply to we'll pop these in there and just turn it manually, just to sort of see with obviously the shells closed up. What we can try and do is this nozzle, we can try and obviously you know, move it and sort of see if it has any you know, jamming issues or anything, if you know what I mean. So and what we can also try and do is actually look physically at the actual sector gear, and then obviously, you know, if we're moving the tappet plate and the sector gear is obviously moving backwards and forwards with the tappet plate as it's moving, so this is one of sort of my like I say, sector gear height tests that I do obviously when doing the shimming, you know, just to double check things, if you know what I mean. So we can obviously try and move this. Oh yeah, I mean, that's back now to its furthest back position, and it's almost physically difficult to actually move it, if you know what I mean. So I mean, I would argue that is not even an if, you know, the gun would work, if you know what I mean. I don't think with that sector gear shimmed that high, if you know what I mean. And like I say, you know, apologies if you know, upsets anyone or anything, but you know, just, you know, this is what I was sort of asked to do, is obviously check on this stuff, and there's no, like I say, hopefully this information helps you, you know, so and it's informative, because it's meant to be instructional. So yeah, so I personally, like I say, would and I don't even think it's a personal preference thing, if you know what I mean. If we're talking of the area of success, you know, that shimming has well and truly found its way outside of it. You know, this nozzle, it would potentially result in a tapper plate failure. Yeah, so and if you go back in time to when tapper plate failures were common, and obviously they've slowly but surely obviously increased in strength over the years. Most of that is obviously to prevent against obviously when people accidentally do this, you know, so where they accidentally shim it obviously too tight, and then obviously it rips the back off the tapper plate, and then we think, oh, I wish we had stronger tapper plates out there, and it turns out to be something that we've actually done wrong, if you know what I mean. But like I say, so changes we're going to make is obviously we're probably going to add, like I say, 0.1 onto the top of this one. We're going to be lowering obviously that sector until we get that movement. We also need to check that to see if there's any play top and bottom of that thing. Just make sure that, like I say, you pop all these screws in to obviously get the gearbox shell into the tightest possible scenario. And then, like I say, just remember what we call step heights. You know, so bevel, you know, sector, bevel, spur, sector, yeah, and then obviously beyond that, you know, because obviously that's what people do is they shim those 3 gears, but you just got to remember that this side of the bevel, it interacts with a motor, right? So you have to think about its interaction of the motor, which we haven't even checked yet, right? And then we've got then that side of it, you know, where the sector is its interaction with the other parts. It picks up a piston, it operates a tapper plate, yeah. So we need to obviously think about and in between, like I say, if we're thinking about shimming as simply making sure that obviously gears spin freely, yeah, and have no up and down slack. Well, yeah, that's an important part of it. So, but then. And this has been one of the hardest things to sort of pick up over the years, if you know what I mean, with shimming. For me, you know, is obviously its interaction with those other parts, yeah. So making sure that obviously, especially with some of the weird and wonderful motor configurations, you know, sometimes that would set a bevel at, you know, a very unusual height, you know. So which then meant that I had then to compensate with obviously bringing up the other ones, you know, possibly higher. And then that meant that then, yeah, so you know, the interaction was then off on these ones, yeah. So you then had to try and find an in between or adjust parts in order to get, you know, that smooth movement between obviously those and also this side. So we're just going to check, get rid of these compression parts now, and we want to check the up and down height. For that, this needs to come out. And we need to recover those shims as they are. Check the top to make sure there's no hidden. Okay, again, as tedious as it is, screws back in. I mean, there's a smidge there. I mean, I may have a shim small enough to do it. And not everyone carries 0.7 shims, so I'll see if I can get one of them on there and see if that is enough to take out that tiny last little bit. Obviously, what you don't want to do is obviously take out so much that when we put all these screws in, it's things. So what we'll do is we'll make the height adjustment in that we will take Let's split these ones out and see what we've got here. Right, 5 and a 5, right, so we've got one underneath. Oh, coffee cold. That's closer to a 6. 0.6, look. Interesting. So we may need to change some out then. So that will lower it if we put 2 5s in there. That may be just enough to get it going free again. I mean, part of me sort of doesn't want to say, do I need to get rid of these bushings? Because we had one that was like slightly askew, didn't we? Do you know what we'll do? Since the shimming isn't spot on, right? We'll start afresh, I think, and we'll knock these bushings out. You know, that way we know for a fact that we're obviously, you know, doing everything. It's going to delay things though, because I'm going to have to pause while they dry. Let me get these tapped out. Because obviously if they're not sitting flush, these the FPS ones or not, do you think? Trying to see if they've been Loctited in. And there's some yellow stuff on this one, but it almost seems like a grease. Right, we'll get these cleaned up and So we're just making sure the underside of these is obviously nice and clean if we're going to be reseating these. So the downside to just pressing in them is that, yeah, I mean, these were in tight, but there is a chance of obviously bowing the shell, and or as we found here, where you sort of bang one in, and because it's so tight, you think, well, that's in, but obviously it's actually sort of, you know, like I say, a slant like that, you know, so it's that one side's gone in more than another. That then means obviously it's sort of an unusual sort of you know, sort of angle against the shaft like that, and then obviously it's going to be putting more tension on one side than another, and you might find that in then sort of the, you know, friction and or binding, and obviously we're spending all the money on these expensive parts, you know, to obviously get, you know, improved reduction in friction and efficiency. So what I like to do is make sure that obviously they just drop in naturally. Yeah, that one's quite close, but this last little part here, it just doesn't. Well, that's not. It has gone flush. And that one's gone flush. I mean, I might take a smidge out. Oh, well, that one isn't. You know, that one's not going in. So we need that one to. We don't want to have to bang that in order to get that in. And the same goes for that other one. Okay, so we know not to take too much out on that one, but these other two we're gonna have to take a bit of out on it. So so we need. If I put that bit. Whew. So to take a little bit out of here, basically with this, we've got this reaming tool bit, if you know what I mean, it's specifically for bearings, holes, and then we're just going to take this a little bit out. running around with a flat blade screwdriver just in case you get these sort of raised edges. We need obviously that bearing, bushing, sitting flush. Here we go. So nice and flush. And then obviously, so now it spins, which is obviously like, oh no, it's spinning, what are we going to do? So, and then obviously that's where the bearing lock comes in, and it's the Loctite 638 compound. It's fantastic. Yeah, so this is the only way to guarantee that everything's perfectly flush. So now that everything's sitting flush, we just need to get it somewhere that we can sort of suspend it either side, grip it with obviously nothing pressed in on the underside, and now it can just grab it, you can just hold it there in place. Right, we're going to prep this one now. They're in, aren't they? Making sure they're not the oversized ones that comes in the kits. Oh, sorry, that's retro arms, isn't it? And these are definitely FPS. So let's see if they sit flush. It's just a smidge proud, isn't it? A bit more out of that one. So it seems nice and flush now. And that one definitely is. I mean, ironically, the problem with Ron originally, which was in for, was obviously the gearbox not fitting in / fire selector being a bit tight. So in doing this, making sure that they obviously sit flush, they will be protruding much further. So then we'll definitely have to shorten the height on them, but we'll double check all that later, just to make sure that there wasn't something else we're missing. Just make sure the underside of these is clean. Okay, so see these. Right, then we're going to pop this to the side, and I'm going to leave that to dry for a bit. Okay, while the gearboxes are setting, so I'm just going to sort of rewire this these damaged wires, because that's damaged and that one's only got a couple of threads left. So it's just, yeah, can't leave that as is. So it's effectively a few more chips on this red. So I'm pretty much just going to pull out that whole red. So I just wired up a red wire to go back in its place. So we'll and then obviously I've got a nice section of new wire just to go in there, and should be able to get that over that. that bit of plastic off, sorry, heat shrink off while I'm doing this. If that's soldering iron. If you need them side by side, it has to be directly in between the sensors and the top solder joint. Righty. I'm going to put some pressure on this. I've got a new tip on there, so it's gone pretty well. I'll try and put the least amount of heat through that. So obviously that's the old cable come off, and not really anything you can do with it once it's got like a little nick in it, you know, cuts and stuff. Oh, there's a slightly bigger one on there. We'll just heat shrink that one up. Oh, such a pain in the ass soldering these things. Make it too thick if we butt clench time. Okay, it looks good. Whether it even works or not, well, I guess we'll find out later. Okay, so I'll finish off that wiring when we install it. Just need to set the lengths. Oh, I could do it now. Okay, so thin wire first. Do about there and leave a little excess on there. So we wrap it around the cable to get a better connection than just trying to lie them across it. Just sort of cut a section, wrap it round, so it's nice and tight against it, then solder it. It's just a smaller, neater join that has a better connection. Right, so in theory, like I say, as long as that turns on, that's all good to get going. So what we have to do is, before it goes on the final build, we've got to solder on a Dean's connector onto there and get it plugged onto the computer to make sure that obviously it's all operating. There's just no point going into a final build up and then pulling the trigger just to sort of realise, you know, that, oh hang on, nothing else works. So it's time consuming, but that needs to be tested before we can, like I say, get anything or other things further done. Also, we want to double check the shimming on this. So we haven't, I think we were doing this one, weren't we? Sector gear. Just making sure everything was all. I think we took some off the bottom, didn't we? I don't think we actually moved any to the top though, did we? A lot of movement. So we want to get at least 0.2 back on the top side from where we removed, maybe even 3. Maths and all that. So don't forget to get all your screws in if you are ever so slightly comes to a halt, which suggests a smidge of binding, but obviously absolutely no slack. So what we might be able to get away with on that is, because it's obviously metal on metal, is obviously just bedding it in for a smidge, but we'll find out obviously when we do the amp test. Also, we just need to double check height of that now that we've lowered it, to make sure that there's the previously not moving air nozzle is moving now. So we're pretty sure we had clearance on the piston, even though it was high, but we definitely saw a non-moving air nozzle. It's physically fixed in place. So we will get that back in there, see how we get on. It was interesting as well, wasn't it? Because I said that there was no wear and tear on the actual tappet plate, you know, indicating, like say, no fouling. But that's because, like I say, I mean, theoretically it never ran like that. There's just no way it could have, because obviously the moment it would have operated, it would have, you know, like I say, the gun would have jammed. It would have produced loads of heat on the wiring, possibly an internal fuse on the MOSFET going. If it would have tried to have moved, but just kind of force things forward, then obviously it may well have broken the back off the tappet plate. So yeah, I mean, it's, yeah, all bad things. Keep trying until you find that correct thread. You don't want to be cutting new ones over and over and over. So if I lean it over like this, it's got a smidge of movement left and right. If I move it over like that, it's got no movement. So that suggests that there is actually a gap, you know, between this, enough to ever so slightly, you know, have some kind of movement left and right, or at the very least the tapper plate's moving if the sector isn't. As I lean over, but the yeah, no, it definitely moves, but just the smallest bit. So even though we were seeing that brief friction where obviously it sort of almost like comes to a halt, you know, this suggests that there is some left and right, even if it's small. So that should be absolutely fine for just bedding in and being okay. But we've still got the issue that obviously this has a smidge of movement. So we'll check it against the piston, and then we'll see if there's any room for coming down a bit. If not, we may have to run it like that. It's obviously, you know, free moving of being bound, which is, you know, loads better than before. Obviously, and like I say, there may be some rubbing, but you know, let's see if we can get it to perfect. Like I say, there's before there was you know, there was in that area of success, it was, you know, it was definitely out of it. Now we've obviously moved it into an area of success, you know, and then obviously then it becomes different degrees of people's perceptions on what is right, you know. So obviously you try and get back down, you know, right in the centre, but you know, you'd be happy for anywhere around here, you know. So it's still centre mass, so to speak. gearbox is quite unique in that obviously you've got the rear view access. You know, if you were trying to check all this on a V2, it would all be enclosed, you know, so it's much harder to do these sorts of checks. Yeah, that's pretty good in that position. That's pretty good. As you can see now, look, we're looking at a pre-optimal for that piston now. In the position of these up against the topper edge, and obviously what we don't want to do is go down too low, so the thick underside of this high torque you know, full tooth gear that is unique to this gearbox and a few others, you know, is making it very thick on the underside, even though this piston is actually half toothed. Yeah, so we don't want this lower edge going too low. So as you pull this piston all the way out, quite a hard one to check. What you can do, it's rarely done, but you can actually flip it upside down. You know, it's just, most people just work in terms of I open a gearbox, lift the top off and work with the bottom, but you know, it's nothing stopping you flipping things on their head and taking a look. So because it's this thicker underside here, you know, we should be able to just cleanly move that, you know, as long as obviously we're staying on the half tooth that doesn't actually have the teeth. I mean, you can see the small gap there between the two, so we do have some, you know, I mean, remember, we literally only need it to be 0.1, you know, further down, so we do have technically the option of possibly changing this 5, even though it is pretty damn close. You know, I think it would have absolutely worked fine, but you know, let's keep going. The calipers, where they at? Well, what done with them? Right, so I found them. I was trying to make this earlier, just 3D printing a block with our logo on just to go onto the back of the gun. I think it came out really well. And that goes on the back of these stocks to replace that. I used to do one ages ago, but I don't know why, but we just haven't got around to making them. I mean, I know why. Obviously we switched over to the Prometheus kits. We just didn't need to make our own anymore, but I want to go back to doing them with a logo on. I think that'll be quite cool. So So as not to lose the train of thought, I mean this is closer to 4.5, so let's try some 2s. Puts us at 3.6 on the underside instead of 4.5, so that has definitely been lowered. That now means that we have to add 1.1 on the other side. Do I have any ones? And then recheck. Ballsed up. I left the just do this check. Now we need to get that piston out of there because that could be holding it in position and stopping it from moving. There we go, see, one or the other. Taper plate and cylinder set, or cylinder set and piston, take your pick, not both. Dee 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 dee. We've got no movement noise. Does spin. so we're definitely clear now. Yeah, I think that's yeah. So just a smidge bit further, and we got there, didn't we? We got there. Right, so that one's good. Top, we're all set on that, and we know that the height is good with obviously the rest of the others. So we now need to check the bevel to make sure that bevel pinion height is good. Fortunately, obviously we have these the best kind of bevel gears, which are these ones here, which means obviously there's no sort of minimum height area. You know, obviously if you accidentally shim the spur gear too high, there's just, you know, you can shim the spur gear as high as you like. It's just a much stronger and better gear than the old V2 gears, you know. But you know, try getting obviously all the companies to adopt it, you know, when they feel like they don't need to, because the old one, you know, assuming the old one's shimmed correctly, you know, it's, you know, I don't know, it's just, it's like I say, it's just very difficult to get people to adopt things. You know, they may well be better, but you know, industries are set up for a certain older thing, and they'll just keep on producing them because it's just easier for them, you know. Right. Okay. Oh, got one here. Gotta make sure you get them all. It's just so easy to forget. You find one, you're like, oh, where'd this come from? And then basically starting all over again just to confirm everything. So you got to make sure everything stays in the right place. Right, bevel. This could be spot on, or it could not be. You know, obviously we've found a gear that's you know, shimmed in correctly. This one could be perfect, but we'll just double check. Yeah. So just to make sure. So we'll start. Might as well just start from fresh, just to make sure that. I mean, it's a tough one. Normally you start with obviously half bevel setup, but you know, and obviously set your motor height correctly. But with these gearboxes, they have a hole at the back here, so you have a great inspection hole to be able to actually see whether it's in the right position or not. So you can technically skip a step and just move on to the next one. So what we'll do is we will put this in the top side. We'll remove the underside. Because what we want to do is obviously find out how much slack is on top, if there's too much or too little. Once the actual motor is set in the correct position. So we've got movement now. So obviously if the you push the motor inside, and then obviously we've got bounce on top of it, that would suggest that obviously we need to come down a little bit, just take a bit of slack out, so it's in the, you know, because we're setting the height, you know, and then we're bringing the bevel to the actual, you know, pinion, as opposed to setting this, say there, and then bringing it in to it, because obviously it could be set way too low, and then no matter what position you bring it to, it's just never right, you know. So we set the height and then we bring it to it, yeah. So that way when you get unusual combinations of parts, you catch those, as opposed to just always hoping that you know, you use the most compatible parts and get away with it every time effectively. So put that in there. so this is the first time we're opening the grip up. I don't like that that's continually turning. Could indicate that there's a that's been cross-threaded at some point. Oh, what's got all right? So we've got a sew link. All right, okay, that's fine. That's fine. Like I say, it's a good motor. Good motor. So 28. Smidge on the slow side. Hopefully you're going to be alright with that in terms of speed. Obviously we're coupling it with a MOSFET, that should speed things up. I mean, let's say, well, I've not used 28, so that's, you know, I normally go a bit quicker, but yeah, we'll get it installed, and you know, like I say, it is what it is. It's the motor that's here, so so we'll give it a go. Like I say, slightly longer motors, and base plates need adjusting, so don't think that's been modified yet. Oh no, that's alright on this one. What was that one the other day that I needed to mod it on? Solink V5 adjustable, maybe they're a bit thicker. Or maybe this has just been wound in a shitload. I mean, that's a long way in for, you know, for an already, you know, I mean, it's technically longer than the TM motor, but shorter than warheads and stuff, you know. So yeah, it's let's wind this out to its furthest out position. We'll pop the spacer in. You see, we are getting a bit closer now, aren't we? And if we need to move it out even further, then yeah, we may need to shorten that base plate, but let's see how we get on with that. Like I say, always get the end plates and always get them on there. There is some markings here where it's, I think, pliers or something have taken the anodizing off. You know, the anodizing can stop short circuits, so hopefully that's not going to be a problem. I could get some tape on there possibly. We are going to get this onto here. Let's see what's going on inside. Let's get one on. Just sometimes, like I say, you just got to move to that next step and just try things out, push things further forward. They were on the gearbox originally, weren't they? Where are they? So same goes for these, you know, just make sure they're technically machine thread, but they are into pot metal, so like I say, go backwards then forwards, find that thread. I do one up loose and then get the next one located before you tighten it. And then you can go ahead and tighten this one and then follow up with the other one. I don't want to put it too close to it that then you try to get the next one in and it can't find the hole, the thread. go. So I'm going to try with spacer first and in the furthest out position to see how far it's sitting from it. I'll try that thread in a second and see if we need to repair that at all. So we'll just turn in forever, so obviously that could drop out in the field, or like I say, not even do anything there really. So I might just build those threads up a little bit, you know, just a little bit of the gel glues, so the thicker stuff, not the super glue, but the stuff that's got sort of you know, sticky, thick gel. Well, it's called gel glue, yeah, basically, a bit thicker. So when you sort of, especially on some of these longer motors, you know, sort of the different aftermarkets, they sometimes do need, and this naturally has, because like I say, I'm using the shimming that was in here already. It's quite a little bit protruded on this bushing here. Okay, so you just got to be careful when doing these and then doing the shim check here, because obviously if there's no gap and it actually physically touches that black plastic that's there, then obviously you'll go to do your shim checks, you move it that side so that it goes this way, and it can't actually move. So it seems like, well, hang on, I've taken out all the slack, but no, it's the actual shaft actually physically touching on the grip there. I mean, it's pretty close. We might have to just modify it just so we're covering our bases. Like I say, sometimes you just got to do best practice, and even though, like I say, it might be fine right now, I can't find a friggin' torch. Yeah, no, I can see a gap through there. So at least in its current position, which is the highest it will allow it to go because of obviously the shims that are inside there. Obviously if we need to move it any higher, then we're going to have to take a bit off that. Okay. So the light doesn't have one direction bearings, so if you're setting up a non-light, the advanced or the adjustable, you just got to remember when turning these that it'll only actually go one direction. So I always click it one so that it kind of like gets everything seated in its correct position, and then you can obviously start doing checks. But we do need to have a quick look in there at the height. Quite odd, you need both eyes for depth perception, so but you sort of almost like want to just close one and so you can peer in there properly, but you've got to keep them both open. Yeah, I mean, if obviously this is the edge of the you know, the bevel, you know, and then obviously you've got the pinion coming in, you know, it's gone all the way in, and the back of it is just ever so slightly sort of hanging out, yeah. So So obviously we could move it obviously in line with the edge of the bevel, you know, but we're probably just going to move it in a smidge, yeah. So just so it's a bit closer in. It all depends though, obviously, on the slack that's available, because we've got very little bounce that's going on now. I mean, there's no slack. So obviously, if we now move this in, you know, bearing in mind the setting that it previously was, you know, literally wound all the way in, and we've now moved it all the way out. So it was obviously set way too close in. I mean, look, we could try and move it all the way in, you know, for like a big movement. It's sometimes actually quite good doing the big movements on it, so that you can actually sort of see too much one direction, too much the next, you know, back. And remember, and obviously if you don't have those movements, then obviously you need to sort of check around here to make sure that nothing's fouling the up and down movement. Sometimes that can be base plate as example. So we move it back out, and then, like I say, back into that sort of, in air quotes, optimal, you know, so that we're obviously getting the maximum amount of surface area attached. But again, we've got this sort of situation where we've got no bounce, no movement on top of that. You know, how do we know that we've not shimmed that too much? Because all that will happen if you have a bevel set too low, right, is that when the pinion comes in, right, to obviously, because obviously the bevel sort of like at that angle, isn't it? Yeah. So obviously, as obviously this new bevel comes in like this, and then in theory the fins marry up to it, you know, all that'll happen is it'll get here, and then when it's then tight, because it can't move any further, it just does this, it just goes down. So all that happens is the motor then does this, so it's actually pointing down, right? So, and then obviously you've got this horrible sort of position where obviously it's working, but obviously all it's done is just move the shaft in the downward, and it's just pushing up so hard on there, and it's just obviously, you know, huge obviously amp usage, potentially going to be grinding things away, all not good, you know. So and it's a skewed reading, because obviously, you know, it should obviously go in there and then be like, well, I can't move any further, but it doesn't, it just moves down, yeah. So making you think that actually, oh, I've got loads of room, you know, moving backwards and forwards, but no. And then obviously, where's all the room there, you know, to obviously see that it's obviously gone in a downwards direction. It's difficult, yeah. So so what we need is obviously we need a little bit of bounce on top. We have to leave that smidge of bounce, otherwise it's got a little bit. Oh, it just goes away then when I move it. Tight again. That could indicate that, like I say, it's moving around, that it's tight one side, tight and not tight the other. I mean, you'd love to think that these things are made exactly perfectly, flat, but yeah, manufacturing. So you always have a little bit of slack in their tolerance. So I think we need to come up, which again means then we potentially need to then do that modification on there, and it does mean that, you know, for the optimal position, that shaft is going to be protruding. So if you use the method, which some people do for shimming, where basically you set the bottom of the shaft in line with that, and the top of the shaft in line with that, and then you bring the motor to it, you would have, you know, quite a substantial amount actually protruding out, and therefore only be using about half of the actual motor. So then obviously, you know, you might find that you just basically grind the end down, you know, to nothing. So yeah, so this is you know, the optimal. It's going to be quite a protruding shaft on this one. So yeah, so we're going to have to pull it up, I'd say like 0.1, maybe 0.2, and then just take a smidge off that side there. So which is the right side. There we go. you know, if we remove this, you know, all that will happen, you know, because obviously you see here it's been installed without one. So obviously if we remove this, yes, it will sit further away, but like I say, we don't want half of this, you know, actually, you know, touching it. We need up to, you know, like I say, you know, bit more than 3/4, you know. So let's see what's on top, what we've got to work with. Okay, 0.17, which could have been a 0.2, but just a bit worn, or it could just have been that in the first place, or it could be my calipers. Where's my blade? I said 0.17, didn't I? So how about if I go with 2, because there's 2 0.17s, go with 2 1.5s. That's going to make it a bit smaller. And it's the top, so we can use up some of these wide ones. Well, that's 1.2 there. 1.13, so yeah, so that's obviously less than 0.17, so times 2, so yeah, that's we'll put that on there, and then obviously we'll recheck, because now we've so the shaft will obviously be protruding higher. Obviously we're not going to shorten the shaft, because just in case we ever install it in a different configuration, but what we can do, like I say, is modify what it's actually fouling on, which is that bit there. So we need the Dremel, and then we just need a small Dremel bit. Oh, I think so. there. Missed calls on my bloody mobile and I never see them. It's been so long looking for blooming tools on this desk. And dropped it. Oops. Flat-bladed. Flat. Grrr. just keep on trying over and over and over until you find that one that's smooth moving and it's not cutting any thread, so to prevent that happening. Backed out just a smidge. I've got a bit of bounce now, so we are definitely close now. So what we can do is we can actually fill in the other side of it, and then we can run it in that position, and then we can listen to the sound of obviously how it's running in this current position. You know, we can do some fine tuning adjustments backwards and forwards to see if we can find one that just really sounds like, say, non-grindy, quiet, nice, and then afterwards we can just double check the position that it's in, you know. And obviously if we get a final position that just, like I say, sounds nice, that looks like it's in a good place, you know, like I say, we're right then, you know. So obviously, you know, if we get one that sounded really nice and it doesn't look like it's in a good position, we could then obviously adjust the height and then go for a more optimal where we get more surface area. But like I say, as long as we're, you know, 3/4 and above, you know, we should be good. Obviously we don't want to be, like I say, into the halves and stuff, you know, just the tip touching, you know. So so yeah, it's but yeah, so we'll fill in this other side of it, and then like I say, we'll run it with a little bit of grease on, and we'll just see what kind of amp readings we're getting from and sound mostly, you know. So I mean, sometimes you can't do too much with it, but we'll, and that's why we put the grease on, because we want to get the least amount of sound possible from the metal on metal. We want to hear what the you know, an incorrect, like I say, wound it in too tight, too far away type sounds, you know. That's what we're hoping to hear from. But we'll run through that procedure next. Whoa, it's quick, isn't it, this? Not. So we're going to carry on putting the shims on the other side of this, and then we were going to do a test, weren't we? So there's all of our slack that we're going to have to take out. So we've got this stack that we took off previously, so it's going to be pretty close, so we're going to pop that back on for a start. quite large ones. And we've got a small one, so let's just check on that small one. So 0.17, so 2. So let's try pop a 3 in there and see what happens. So 0.25, so I think it's more than 0.17, and it seemed like a smidge of slack in there, so we'll pop him on and we'll see what it's like now. Yep, it is quite raised, but it is what it is once you pop a new motor in there. Here is this collar aftermarket. Maybe. Yeah, I think unless we get magically the same shims, but like I say, a smidge bigger, because like I say, you can get a 0.3 shim that's like 0.29, or a shim that's 0.27, so we might be able to eke out a tiny bit of extra, but it really is like no movement at all, with obviously, so I think that's about right. Obviously what you don't want on the bevel is obviously too much play, because as it's running at high speed you get this sort of skipping, as it's going over the top of it, which obviously can create sound, because obviously it's moving up and down, and it's just sort of tapping on the pinion, which creates this horrible noise. So what we're going to do is so grease this up, because obviously we want to try and remove as much sound as possible for this test, to try and obviously infer, you know, whether it's set right based on sound. So we're going to pop a basic loop circuit in there, so just to create a circuit with the motor. Right. So it can be difficult with these slightly bigger motors, getting the wiring in, and making sure that you do have adequate play up and down on the motor, because obviously if you make an adjustment here with no play, then obviously you're not going to get the results of that that adjustment, you know. Put our inline amp meter on there just to get some numbers. So we know it's going to be too tight if we go in a bit more. You can hear the sound. We've got a 2.58 peak, so just remember that, because we just need to double check in a second after just running it for a smidge. So it's quite far backed out on here, so obviously this screw is quite far out, and that's obviously with the motor spacer. So theoretically we could potentially remove the motor spacer and just get this thing sitting in a bit you know, closer in. That could potentially be an option just for aesthetics, you know, with regards to this. But you know, I mean, this is just an adjustment screw. Theoretically, no one's catching this or rubbing that, if you know what I mean. And also, obviously, if we wanted to move this in with the motor spacer, we would have to potentially be like I say, where it's currently at in like I say, like a nice position just off the with the bevel there and the pinion there. We would obviously have to move the pinion in, and that would obviously, you know, you can hear it obviously immediately grinding when we do, which means we would then have to raise the bevel more, and it's already, you know, like I say, protruding from this bushing here, right? So if anything, like I say, we sort of don't want that. We want it, like I say, maybe even potentially further out, and then actually lowering the bevel, so that's obviously it's sitting more centrally, if you know what I mean, in the you know, in the actual gearbox, if you know what I mean. So we obviously don't want, you know, like that much shims, you know, underneath it. But ultimately, like I say, this is the correct position, as in you know, like I said, the majority of the pinion, you know, pressed up against, you know, the gear, and you know, i.e. sort of, you know, similar to obviously how the original TM ones come in, you know, alike, with obviously the majority of them, you know, put up against the bevel. So we've sort of matched that sort of similar position, and obviously all techs do as a general rule of thumb. But yeah, obviously if we move it out, you know, yes, we could probably drop it down, but then I will say it's going to be even further out then, you know, and or you know, yeah, it's just like I say, you know, this is I think this is about right, if you know what I mean, for the setting, even though like I say it does look unusually wound out. It might have been fine with the previous one because it wound in like excessively before, but obviously if you weren't using the motor spacer, then they might have accounted for that, you see, so and why it was so wound in. We're going to ping it one more time just to kind of see what the numbers were. I think we said 258. So we now got a 194, so just from that initial sort of when we first started it, it got a high average. Then obviously it runs for a little bit, if you know what I mean, then you get, and the next one is a lower one. And you could potentially keep on doing that, and this is why we sort of simulate the spinning right now in this scenario, in this situation, because in order for you to get that amount of revolutions, you know, in a game day, it's just not going to happen, you know. It's just I mean, you could argue that somebody's never going to that amount in their entire life of gameplay, you know, of owning the gun. So we run it for a period of time, in air quotes, bedding in, you know, so with this new layout, and yeah, and then theoretically, if people really wanted to go to the nth degree, you could then go in and reshim again, you know, and then potentially take out more slack and stuff. It's why, you know, let's say if you go in 6 months later into a gun and do a service on them, even if we've, you know, previously shimmed a gun, we tend to double check the shimming, yeah, so just to see if there's any slack we can sort of take out. But even if there is slack, like I say, and somebody just think, oh well, I say like where I've caught like one thing got a tiny little bit of extra slack, we're only removing that slack because it's best, you know, practice, yeah. So and we try and get as close to, in air quotes, perfection as possible, and like I say, some people get really hang up to the point where they're actually calling out people's shimming as bad. It's not. We're all just got our interpretation of like I say, the circle, and trying to get into that area of success, yeah. So and like I say, one person's perception of success is over here, another person's is over there. Obviously the main thing is obviously that we're all aiming to try and get into that circle of obviously it working, you know. So yeah, like I say, I think we've got rid of a lot of slack. You could hear that there was no that sort of jumping bounce that can happen, you know, the skipping, you know, from from obviously too much play, where it's sort of just going to you know, as it's got that sort of play as it's bouncing, as it's running over the gears. So like I say, nice and you know, non-screechy, which is good. But I think it was like back when we started first fitting the warheads, you know, because of the extra length of those motors, Andy would do repeat builds, and it was just constantly screeching, and I'm just like, so we end up having to look around the grip area, if you know what I mean. It turns out, like I say, a combination of really tight wires and a base plate modification that was needed, you know, was obviously forcing it in too much. So no matter how many times he would obviously shim up the thing, his results would be skewed by the installation of the motor, you know. So yeah, it's yeah, it's just shimming, you know. So and then like I say, this is on a gun, you know, that obviously you know I do quite a lot, you know. So and then there's, you know, adding in the complexity of if I was to take this off the bench right now and put on here, I don't know, an AGM, you know, so immediately the word China, you know, so you know, so a China MP40, you know, so you're adding the complexity that obviously there could potentially be quality issues from the China, so where obviously one thing is made this big, another thing is made that big, you know, and then you've obviously got the weirdness of well, what even gearbox is in the MP40, you know. I literally have to Google it. I think it's, you know, its own unique one. I think it's like nondescript. It's just the, you know, it's for that gun. Last time I checked, I think when I had to do one, I think it didn't have actually a motor adjustment screw, so there was no adjustment screw on it at that particular time in its development. Yeah, how do you set and do this exact, you know, dialing in the motor if you know, if you can't adjust the motor screw. So yeah, it's and that gun exists in the world, and people use them every day. So, well, not every day, but you know what I mean. So to game with, and you know, that's you know, so we'd have to get this on here. We'd have to then somehow get good at that. You know, and let's say it's just never going to happen on the first go. You're just going to have to sort of, you know, keep on working at it, and yeah, get there to hopefully you know, become excellent at obviously shooting that particular one. Learn its eccentricities of obviously, you know, I obviously look through this inspection hole to obviously get the motor height, so obviously you're going to have to learn what the trick is obviously on the MG40, sorry, MP40. You know, what if you're working on something like a Scorpion, you know, ASG Scorpion's got absolutely no vision whatsoever. PSG1, no vision whatsoever of the motor pinion. It's a completely enclosed gearbox, you know. So we're just going to add in the other three, and we're just going to double check that the step heights are correct on everything. Okay, so another benefit of obviously running this gearbox as is, you know, bedding it in for a period of time before introducing the MOSFET system, is that obviously any excess here is going to splay now, while getting obviously a good coat of the gears, and obviously all that excess just splays off. What we don't want to do is obviously it splaying off while the MOSFET's just been installed, and it obviously going over all the sensors and stuff. So a lot of gun techs would go down the route of just simply applying very little grease, you know, when utilising optical MOSFETs, but you know, I prefer this method. So we get to put both grease on, which obviously get the benefit of greases on metals that are, you know, rubbing against each other, but you know, we can obviously rule out that problem of obviously, you know, going a couple of game days, if you know what I mean, and there now being grease on a sensor. So yeah, which can happen obviously when you're you know, building guns en masse for people. So yeah, so we're popping in the this one. So we've got, even though that we've got this height here, obviously the spur gear has already been shimmed, you know, high enough, if you know what I mean, to account for the extra height of the bevel. So we've got a nice full contact, if you know what I mean, of this lower ring, and you know, going around, so that, and it's just like I say, it's in full contact with there, so it's not like half of it or anything like that, which is good. I wanted to just put a little bit more black length on there. we need a sector. I believe on these Solink motors, the light versions, underneath these caps is a small switch where they would have done the advanced switch on there. I don't know if that's, I haven't really investigated it to see if there's any sort of options for playing about with that. I'm just going to pop this last screw in here. You never know, sometimes that was the issue we had with the MP5s. It was skewing our testing results. There was one screw over here and we popped it in on the final thing, and it sort of almost like torques the gearbox shell to the point when they were too tight on the shimming. Very, very crazy, but that's why we always make sure we pop all the screws in so that it never catches you out. Yeah, bearing in mind 15 years ago we never had such things as amp testers and stuff, you know. It was just like, oh, my motor grip gets hot, so, you know, oh no, it's normal, it's fine. So you just, you know, shimming's perfect, honest. So we put all these checks in here, you see, because of in air quotes human error. You simply cannot get away from, you know, you can do everything right as a human being, and there's that impossible 2% you know, human error rate, if you know what I mean, that could never ever, you know, that concept is, if you Google, you know, what is the official human error rate, you know, it's never zero, you know, it's absolutely impossible to be zero, you know. Like somebody at some point, you know, I'm going to mess up, you know, on 100 guns, 2 of them, it is an unfortunate fact, yeah, so of life. And you know, obviously, yeah, I could just accept it and be like that, that's it, you know. But obviously what you're trying to do is keep it at that 2%, is keep it just at that 2 guns, you know. So you know, or like I say, try and get that error rate, you know, so that it obviously doesn't affect the customer, you know. Nice. Yeah, it's just gone just right there. We've just got the wires in just the right position that they're not pushing on it. I've got a lovely bounce. Look at that. really nice. Yeah, it's why it's so important that obviously motor grip wires are as thin as possible, so you don't get the fouling on the motors. That's why they use these thin Teflon wires. You know, they don't have that sort of sticky silicon coating to them that's often very, very thick, even though both wires are 16 AWG inside. These ones reduce the overall diameter of the wire, so thus making it much more compatible. And it's only going to continue to try and shrink on the internals. It's just what happens. You get this, airsoft guns. It'll take a long time, but they're eventually going to follow the process of mobile phones, where the mobile phones will obviously just keep on shrinking their insides and try and obviously reduce the technology as small as possible, while obviously increasing the speed of chips and making them faster and faster. And then obviously they reach a sort of point where obviously the technology won't allow it to go anymore, so then obviously things change where they think, well, how can we expand a product? And you get things like obviously the recoil guns, where they actually physically add a feature to the gun, so they're not shrinking things and making things smaller. They're then taking that space that they've then created, to then add an extra feature in there. So they add a recoil system, which now fills up the space. Mobile phones might add a camera, so that fills the space, and it adds a huge feature. And ironically, with obviously mobile phones, they've been getting bigger and bigger, ironically, as people demand more and more features on a portable computer, so yeah. And at some point, which I think they did in Apple's latest iteration, I think they tried to make a smaller, slimmer, lighter frame, so to actually reduce the overall weight of the phone, so because obviously it's been getting bigger and bigger and bigger over the years and stuff. I mean, I picked up my old 6, I think it was, and it's tiny, it's so thin and so small, this little sliver of a phone, and that used to be like big, so, and I've got my Pro Max is like this, what I mean? So it's like, yeah. So we've got this in, so obviously we're just going to run it. So I just want to do my initial checks with the amp thing, just to see what the initial, calorific reading is, and then we'll see what the slimmed down version is after we've run it for a smidge. The battery ran out. Sorry, the SD card space ran out. I think I was nattering away, and I don't actually remember when it ran out. So I've just emptied the card, and yeah, I'll carry on, and hopefully I haven't missed too much. So if not, I can't sort of go back and magic that back in. But hopefully it doesn't make too. Looks fairly alright. But we'll carry on. Like I say, we're going to go through here. We were modifying the bushing. Well, that's pretty damn smooth, so maybe we don't need to modify that. Let's get that built up, and then we'll see when we get all the other bits in there. Just make sure the fouling's not coming from somewhere else. For fuck's sake. Just stretch that O-ring a little bit just to get a slightly better seal on that while we're building up the rest of it. I've not really got the old settings. We tend to do old and we tend to do new, but so obviously sector, top, bottom, spur, top, bottom, bevel, top, bottom. Okay, so if you know, I don't know, I sneeze or something, you know, and like I say, all these guys fly in. Now that we're obviously happy with the results, you want to take a bit of a picture of that moment in time. You know, so that it can be fairly effortlessly recreated.
UPS.
Oh, there's no UPS today, so
No, there isn't any today.
So we've got another top over here. So just put that back over there. Okay. .28. So 1.28. So none of those bushings anymore. 0.68. And we've got 0.98. Okay, so there are your numbers if you need to recreate it. So okay, our test cables can come out, so we don't need them anymore. So I'm just going to take off some of this excess grease. So all the most modern ones don't really need the polishing. Used to be that they get the casting marks, but the new ones are, the latest revisions are pretty good. The R1 versions, revision 1. You can take obviously something and just run them up and down on the actual runners. A flat bladed screwdriver is quite good. Obviously you're checking for burrs. If you want to polish it, it's it's not a problem. So can do, but I've got no sort of tangible gains that I can sort of promise from doing that, unless there's any binding, which there isn't. So we need to try this. A nice flat surface for the MOSFET to sit on. Don't want any burrs or anything sticking up that might go through the varnish that's on there into the circuit board. Now we've got our new FET, new wiring. So we want to lift our wires up. We want to start with the smallest wire, get him tucked right down low. So we want our black wire next, which is going to be going out the back. And we want to press this down so it kind of like folds over the smaller wire. That's going to hold that down, and then we've got another wire, the black one, to go over the top, which is going to hold down those wires once trapped in place. Okay, I think you had like a little wire thing to hold some wires down, but I'll be honest, I don't think it did its job. Is it somewhere around here? Something like that maybe? Okay. Oh shit, we're going to have to pull them out. So get the flipping screw in. Right, you. Okay, so you want the metal washer on the top. So this all has to be moved out of the way. Maybe that was where the error came from. So we've got to make sure that obviously as we move these we pop it all back into. Oh, flipping hell. Make sure it's all flush. So you want it going down the middle, obviously nice and flat. So if you need to, that same roll pin that you can use for at the bottom here for getting the wires nice and flush, and just roll this on here. Which is easy for me to say because obviously, you know, effectively all the broken wiring is highlighting the problem, which is obviously great when, you know, the problem's highlighted. Obviously if you don't know, because it's not been highlighted, then obviously, you know, it's easy to do the problem, isn't it? Okay, so if we've got all that jotted down, I can get rid of the paperwork now. wiring done. Pop the trigger in. Make sure there's clearance on there. We need to gears pretty much, I guess, and then cylinder set. Wiring can be thrown. Yes, it just stops straight away now. I mean, you know, it can deteriorate over time, but at the moment it's currently good. So we've got a second tooth mod. AOE is automatically adjusted on the FPS products, so no need to do any of that. Okay, all of our gears are all pre-greased, as is our bearings, because obviously that's already been done. So we've got a Solink light motor. Okay, so anti-reversal latch will need to go back in then. So if you want to make them a little bit more positive, you can just slightly put a bend in the tail, just to put a smidge more pressure against the gearbox, just so it's a bit more sort of sprung in its operation. Friggin' bevel gun. Selector. Right, it's the guide for the link arms. Put them on in a bit. So you get 3 screws that are self-tapping, countersunks. The longest one is obviously the grip, and the shortest one's for the grip, and the medium one being for the gearbox. So we've done all of our clearance checks before we obviously install all of this, to make sure that obviously the tapper plate and the piston all clear the sector gear, so we're happy with those results. So, motor spacer, those parts, guide going afterwards. sure we pop that back in. Tappet plate, spring, and everything else is externals related to building it back up. So yeah, it's all looking good, isn't it? So we can get our obligatory photograph, you know, before we get it all put back in. Why not? It's looking all shiny. Nice. So again, we're going to tuck these wires in. So remember, you can push this one down so that the sort of smaller wire gets kind of pushed along its side, and this top one is obviously going to hold that one down, and this one's going to hold that one down. And then take our casing. Obviously we've got all parts in, 90 degrees on the gear, and now we can close it up. So check you got piston clearance and you haven't caught it onto the actual runners themselves. Make sure this cylinder's obviously in. Tappet plate's free moving, and now we can start piecing together the rest of the gearbox. So we want a smidge of Loctite just on the surface, just here on the surface, and again all the way around on the surfaces. We want to get it trapped under the pan heads. As opposed to putting red Loctite on threads. It can be a pain long term for maintenance. All we want is to prevent it unwinding. So again, same as when you were doing the shimming, just because it's the last time, we don't need to over tighten anything. See, we want to go into those resistance, then just nip it a smidge more, and that's pretty much it really. Obviously what's going to stop it unwinding is obviously the Loctite that we've just trapped underneath that head, and once that goes off, it's going to form this bond, which should prevent any sort of unwinding happening. And obviously if that initial unwinding doesn't start, then obviously it doesn't then get loose and or screws drop out. It's that just stopping it getting loose in the first place. We've got a bunch of spare wires, whether we're doing CTR stocks or we're doing wiring to the original, quick connectors. And we can do all that with our extra length, and we can just cut the excess off. Oh Jesus! Right, so a little bit of grease on our tappet plate spring as you pop him in. Where's that sandpaper? So just this sort of screw here, but like I said, it does technically go up into a runner, so it would have to be protruding at absolute crap amount loads, to cause a problem. just get rid of it just to make sure. Or it's where the runner is, so I will get rid of it. Better safe than sorry. It just takes this screw, like I say, flush. And it's nice and smooth. Make sure there's no fouling on there. So if you are going to glue that in, don't put a lot on there. You want to be able to, like, so break it off if needed. So tap a plate spring in. Right, let's get this in. See if we can get this grip located. Beep, and through there. Tuck that wire through. that's going in nicely, so we'll lift this up and have a look here. Ah, friggin' bolt stop levers. How many of you are screaming at the screen? Bolt stop lever, it's behind you. Just a smidge fiddly while I got in this position. God damn it. So it's got this shouldered or collared screw, however you want to call it, with like this sort of, like hat type edge. You want to make sure that obviously this spring is underneath of that and not on top of it, because if it's on top of, obviously you're not going to get that correct operation. So then you just want to basically give it a spring like that, and it should obviously bounce backwards and forwards properly. Get our thing back in place. This is going to keep falling off because obviously we've now taken everything that would have held it off. With obviously the original trigger sets. So once we get it back in, we can just basically stick it in full auto, rock it forward. We can just pop this in, make sure it's on top of the lever. Obviously gearbox position is going to be really important. Okay, so we've got our locating pin there, so now what we need to do is tuck these wires over. We need to get a sock tube, and we need to thread it in here while tilting the back with gearbox down, and that's now going to align our gearbox. So we don't need to do it up tight or anything like that, so just obviously so that that's putting the gearbox in the correct alignment. And now we can obviously add the grip. What we don't want to do is add the grip, then pull this in alignment, as the gearbox can tilt upwards and down, and we obviously need to make sure that everything's put back in its correct position. So you can see the wires inside there. So like I don't know if the video caught it earlier, but we use the roll pin to basically just make sure that obviously our wiring is tucked neatly. You just want to rub against it. You don't want to be like pushing too hard that it breaks any wiring or anything like that. But obviously we need to make sure that this is clear, yeah. So it needs to be, so no pinion is going to obviously get caught on anything. And the same goes for after we've obviously fit the grip. So I like to find the hole for both of them, and then you can then tighten them up. It's a bit like a car wheel, you know, you want to try and do it evenly. There we go. We don't need to over tighten it. Obviously, we don't want the grip being loose. So when the customer's obviously moving the the gun, obviously you don't want any sort of movement in the grip, obviously. But obviously you don't want it a bit so over tight that obviously we're pulling through cast metal. It's not the most strongest sort of stuff. So we over tightening things can be bad. So if you want things just to not unwind, use Loctite or utilise Loctite. So. I'll turn the heater off. Oof. Crikey. Sounds like raw mount. sort them out. Tighten that up a smidge. Oh crap, we're doing the grip mod. Crazy amount. What we need is the this sort of thicker, tackier glue grip into the threads that are already there, building up on it, and then if we need to, we can layer it up. Hopefully that's enough to give it something nice to cut into. So we can just keep building up until it keeps getting smaller and smaller, that whole area, and until eventually, like I say, it's almost like it's cutting something new into plastic again. But you can do the same with like filler as well, and then re-drill it. And you've got sort of options, you know, for repairing these things. Right, I've put the lid back on the glue because I'm terrible for that. And so we've got a Dean's connector on there now, just temporarily, just shoehorned on, just so we can obviously do our setup and testing. So obviously before I go any further, I'm going to just go into the other room and just double check the MOSFET is working. Obviously if it is, then obviously we can continue further. If not, then obviously we've got to go back in and well, probably replace the MOSFET, but hopefully everything's all good. And we still have a spring to pop into the back of here. So now that the grip is set, we can just remove this and treat it as normal. We've also got a magazine release to put back on, but we'll do that in a minute. Oh, and we were waiting for the grip screw, weren't we, if you don't mean to put back on. That will be drying soon. Okay, so spring guide is not upgraded. I mean, you've technically got all the others upgraded. We could do that. Ping your messages and see if you want to do that at the same time. While that's off, I'm just going to quickly pop this off. Okay, so we have like I said, there's 2 screws just to go back on, and the base plate. Shins we'll put to the side so it doesn't confuse the next one. Getting it out of me. Fork. Pin's gone, so we'll have to put that on an invoice for you and replace it with the laylax one if that's alright. So otherwise that pin's just going to keep on coming out. Could Loctite it, but there's no guarantee it will stay. Hammer. Okay, so just going to put this over there. We'll let that dry, and then obviously tomorrow I'm going to pop that on there. I'm going to range test it, and then we'll do final reassembly. Okay, so we've done some range tests on this. A couple of things to note. Obviously, you know, the reason we function test guns is to obviously make sure that because there's one thing putting things physically together, there's another thing to actually game with something. So we, you know, obviously tested it, and one thing to note is obviously this type fire selector is back again. So we've fully assembled the gun, and it's now something's pulled something into a certain position in order to recreate this problem, so coming back again. Yeah, so when we tighten things up and something's moved, a small tolerance enough to now interfere, as opposed to previously when we were testing it, because you saw on camera that it physically moved and was clear, to it now being incorrect. So we've got to go back in and we need to try and figure out obviously what that's fouling on, because obviously it's not moving successfully obviously into the right positions. So also when I haven't done anything with the hop area, if you know what I mean, it's, as the customers provided it. I'm firing single shots, and there's you fire one. So if obviously you just fire a single shot, and sometimes it's a difficult thing with obviously testing. You go out, you fire a couple of shots, and you set up the hop, and you go back in and you set your FPS, which obviously we've done. For 3.2s. The problem is when we were spamming, a quick succession, the single shots, then it created a splay of shots, almost like flyers, off to different sides and different angles, which that could be broad, incredibly broad as to what that could be. So obviously, all we can do with obviously the accuracy side of things is obviously try and reseat what's in there currently, maybe clean it, maybe just try and stabilize the barrel if there is anything to stabilize, reseat everything, and then obviously once that problem's resolved, because obviously I don't want to continue to use that with it being tight, we then retest again, even more time gone, obviously on trying to really dial in, none of which is, like I say, just the pure building of it. It's the extra. So like I say, so that's why, gun building and gun teching, holistically, is not just going in and installing a spring. And this is absolutely for people at home. It's going out and taking what you've built, and then obviously spending the time to make sure the sniper people, when they've ordered the sniper builds and they say, is there any chance you can zero the scope in for me? That is all part of the build. You're meant to be going out and doing that, so yeah, it's like I say, so when people are obviously building these at home, like I say, it's and you get the spring installed, and you're done in an hour, that's not just it, you know what I mean? So there's all the more. Does it, when you try to use it for a whole day, can you get a full day's uses out of it, or does the battery efficiency tank? When you use it for the whole day, is it shooting straight, or is it all shooting to the left? So just like I say, that's and there's so much, because I just want to keep working on these guns forever, but at some point, you have to be like, look, this is 99% there, it's time to go back to the customer. But yeah, I mean, that's the if you go back to the first ever sort of guns, that any tech does, it's ultimately their own gun, and you work on it all the time, week in, week out, and it's never ever truly there, so you just always keep working at it. Obviously what we try and do with these packages is we're trying to do something sort of out of the box, and that somebody gets 95% to that, out of the box, without obviously spending all that time trying to get that last extra 5%. And the manufacturer's obviously trying to do it, but obviously there's a 40% short, so yeah, I don't know, it's a bit of a rant. But right, I'm going to get this split back down, and we pull this apart. Yeah, so still tight as anything. Still tight. I'm assuming it's something to do with this grip pulling the gearbox down. You know, we've set the position of the gearbox correctly with obviously the stock tube at the back here, so we know that it's you know, the gearbox in the correct position. So for some reason this gun doesn't. I mean, this is the problem is it has to be something that was introduced from the previous build and from our build. I would imagine, you know, protruding bushing is going to be sort of, as in we were umming and ahhing about it. We done the test initially. We deemed, you know, that we didn't need to do it, but you know, it's looking like we're probably going to have to do it, isn't it? So, even though we can't see any sort of clear evidence of fouling. stuck. That means fire selector is now in the wrong position, so back in a minute. Okay, so the disc just inside here is basically turning, it is in oval, yeah. So effectively the damage is caused already on this, if you know what I mean. That, you know, it's now obviously effectively slipping because of obviously whatever the interference was. So now we have the issue, and it's very common because we get asked for these all the time. About obviously, you know, so we could obviously potentially glue this in place, which obviously isn't fantastic for repeated disassemblies. So a possible solution is me manufacturing one. So I have just done a quick prototype just to see if this is something that's doable. Because obviously, you know, you can make something, but obviously, is it robust? Does it work? Is it the right size? So it's currently in there at the moment, and I got a very similar fouling issue as well on this particular one. So it's Very odd in that do you know what it might possibly be? Because it seems to be, as we pull this back into the furthest most position, I think it's this pin. So because this pin has been hammered, I think it's sort of, I don't want to use the word bowed, but I think it's further in, because it's only when we pull it back and when we move it to the furthest rear, and then we start getting this fouling. You know, it has to be obviously when this is perfectly in line. That's why it only appears obviously once it's fully assembled. And then we start doing this, and we start pulling it back, and we start getting this position where it's hitting. So it's not actual fire selector hitting on anything, that it's moving the selector plate into a rear position, and because there wasn't sort of massive obvious signs initially, but I think if we could just shorten that plate. There is a mark at the bottom there, almost like an indentation. Is that where it's been pushing up against it? If that's in there, it would be more akin to the back here in the middle. Somewhat reluctant to shorten that pin that's pushing through, which is just in there. But I mean, initially the new replacement that I've made, that seems to be working just fine. We just need to resolve this fouling issue so that obviously it doesn't happen again. Yeah. It's physically touching that, isn't it? In that furthest back position. I mean, in terms of functionality, the rear of this plate does nothing. You know, if we had a selector in there, obviously it might be just pushing that down, that cut-off lever. But yeah, like I say, let's just shorten the back of this plate and then see if we get a better movement. Just want to move this one further forward. I'm just trying to keep up the pace. on gun builds, but it's difficult because, you know, how many times you worked on a gun like this, and you know, here we are with yet another problem to resolve. You know, and it's been years of working on these things. It just seems to be problem after problem, doesn't it? But it's manufacturing and manufacturing tolerances and a combination of aftermarket parts. Where's my Dremel? Loads better, yeah. So that's all it was. It was for some reason hitting on this pin at the back here, which was causing it to obviously get into a tight position, so effectively it would be difficult to move to that position there. That then obviously caused it to you know, knock the selector round, and obviously once that had turned oval, the oval was moving, and then it was just almost making it feel tight in all positions then. That's why when I reseated it to its correct position, it restored it to operation until obviously it then tapped that again and then put it back out of position. But like I say, once it's gone round, you can't trust it from then onwards for reliability. So I think it's better that we obviously changed it to a new one with a nice flat on it that you know, be better. So I just need to reassemble this now, don't we, and then give it another test. And then we're obviously reseating that hop rubber, aren't we? Okay, I think I can see already. I mean, this barrel is incorrect, I think, for this gun. So this hop clip here is struggling to go in. I've seen this before. The barrel's too long. I think that's pushing, obviously making it really tight on the hop rubber inside there, so it's going to be bunched and, you know, cause the splaying shots. The nub's not upgraded. Oh, hop rubber's in here then. Jeepers, that was tight, wasn't it? I don't know if we're going to have one of these. Shit. I mean, I'm not familiar with the bucking. Sort of looks like that sort of KWA style with that slit down the middle. PDI maybe. That sort of W style. I've got, we can go up to 280 on this thing. Well, let's do some investigating, because that barrel, it's got this huge wide cut on there, so it looks like obviously it would be a wide cut with the expanded window, but both the Crytek one has a different style, as does this one, so we're going to have to investigate. So we've got 22.25. So 22.56. So that is a smidge longer. 22.64 on this one. I just don't want to try and persist with it. Feels like really nice quality. Problem is, like I say, if that's not pressed in, and that's why we can't clip that in. I mean, I could try and reseat it one more time, but I feel like I'm sort of just going to waste some time here to try and fit a part which I don't think is compatible. But then obviously if we then fit this one, it's bloody 300mm. Potentially going to be into the in the front here. That's all I've got. I'm just going to trim a smidge off that hot rubber. NGRS hot rubbers are ever so slightly shorter than normal ones. So if this hasn't been trimmed, that could be causing the fouling. It's quite tight on this one, so need to lube up inside there. Allows us to get a nice slide in there without actually I mean, it's gone straight in this time, so might be alright there. So it's not protruding anymore, if you know what I mean. It's not sort of sticking out, so it could have just been that was slightly too long or not quite pushed in, creating a bunch in. Okay, I'm not a huge fan of the barrel nubs, so we'll put on one of the concave nubs, or Omega style would be the best way to describe it. So see that not fitting in there? That needs to be modified. There needs to be clean movement going up and down. It's amazing, isn't it, how much mods need to be done on parts to actually make them fit when you just buy them online. And surely everything should just fit, right? There we go. So, because if it isn't free moving inside there, as that arm goes up, as the arm pushes down and then the arm goes back up, it just stays down. So it's obviously stuck in a permanently on state. That can happen with the MWSs quite a lot. Okay, so I'm not fitting any of the other parts on here because what I just need to do is quickly see if this has even resolved anything. Problem is as well with using 3.2s, it can hide a lot of sins with obviously how accurate the ammo is. Alright, I need a body pin. I might have forgot to carry on with the video just for the after we've done our range testing, but yeah, I've basically just pulled the wiring through, obviously set the stock in position, obviously put this connector back on, and just shortened and soldered these wires to it. So now we're just going to put these in place. We're going to pop this on and this cover. So when you pop these in, that can pull this down, this connector down at an angle. So if you have a look on the TM wires, they're actually bent at an angle, so you can put a angle in with the screwdrivers. Just press down on here and then angle them. It just means that they come down at more of an angle, so that they're not actually being pressed up on the edge of this, and therefore it pulls this then down like that. You want obviously equal surface area from both of these prongs. So we can feed any of the excess wire underneath. Put this cover on. You just have to keep wiggling until it finds the hole, and then we can pop this over the top. So what we'll want to do is pressure that down. We can use some grips that will hold that against that. Just a smidge of Loctite on the surface. I'm going to try and avoid the threads, just to get it onto the surface. So always go backwards to find the thread. If there's any resistance, keep going backwards until you find it. Okay. Once it's tight, you can take that off. I'll raise it up a little bit and put the pressure on the inside of it. So we need to tighten up this locking ring. So for that we can use this jig. Just going to set that in line with this so that we don't have to sort of mess about trying to line that up. Okay, we're just going to need a little bit of Loctite between the upper receiver and the threads, and then a little bit more here. So once the Loctite goes off, and that's the key, is obviously getting the Loctite to actually set. It shouldn't be something that can be easily broken, so then we shouldn't need to crank this up too much. So we usually go up to, like, you know, you feel the pressure, and you know you can't really go any more by hand. Then a couple of taps just to go a little bit further, but never too much to be like over the tightening thing, so we don't want to cramp it down too much. And then we need this to go off, so before we can use it we've got to let that set for a bit. But now we've obviously got this, so it's now just a matter of putting the stock back on. Obviously it's got the conversion kits installed, and that's it. So red on the left, red on the left, make confirmation. That's it. We've got the wireless stock system inside, and the Dean's conversion on the end there, and yeah, easy peasy, eh? Right, so that's all done. We hope you enjoyed the video, and hopefully it's useful to people that are interested in learning these things. And yeah, thank you very much for using us. Richard speaking from Airsoft. We are going to be testing this TM MK18. So this has had a rear build, which there is a video actually attached to this one. So so if you skip to the end, this is just the testing part. We did quite a lot, so it was obviously covered on the video. Obviously parts wise, it's just a new Dean's bar kit, FPS spring guide, and the trigger pin going through the middle here. We did 3D print a new cover spacer to go on the back of the fire selector, so that and then we modified the bushings to be a bit slimmer, so that obviously that fire selector damage doesn't happen again. I think we repaired the grip screws, which we didn't mention, which we did on the Mark 46 video. We did that as well on that one. What else did we do? Chronode 271 on 3.2, so it's a good FPS. Just rebuilt it up. Yeah, there's a lot of sort of niggly things. We did have an accuracy issue, I think, which we sorted out. I think we were going to install a different barrel, but in the end I think we didn't need to. I think I went over that on the video, but yeah, I mean, I just want to sort of quickly demonstrate it. I'm keen to get this rock and roll in. Since I still have to add this onto the other video, and it takes a little bit of time to do that. Plus, if this doesn't work, it could be a real late night for me. So, since it's being collected tomorrow. So it's already had its range testing and stuff, but obviously we need to stress it, you know, just to sort of see if there's anything, if we start blasting a lot or try to use a lot of rounds. Okay, so for some reason there's no full auto, so we might need to address that. Okie, so single shot's working fantastic. So what I'm going to do is off camera I'm just going to reprogram this. If there's another one I'll add it on if I have to do another video, but otherwise I might just off camera just make sure that obviously it's fully working. I mean, the main thing is to test it, and as part of this process and the videoing is to kind of like, you know, force, you know, me as a gun tech, if you know what I mean, to obviously test their guns before they go out, because it's just so easy to be like, well, yeah, I'm sure that'll be fine, and then obviously find out a gun hasn't got full auto, so for whatever reason. So obviously I'm gonna go reprogram it, and then we'll because like I say, it might be a original user setting from customers' personal preferences, you know. So but yeah, I'll go and you know, change that, and obviously if you do want it set on single shots, let me know, and obviously I can put it back there, but I do need to technically test the functionality. So but yeah, thank you very much and hope you enjoy. Okay, so just a quick with a full auto test. There we go, so all tested. Any problems, let me know, but hopefully everything's all singing and dancing for you. Thank you all.